All right, welcome to the notes for Unit 3, Day 1. This is called the Binomial Theorem. And before I can explain what that is, let me kind of introduce you to some patterns here that might be helpful. So the first thing we'll look at is, I think anything to the 0 power is automatically 1. So if I'm doing a binomial a plus b to the 0 power, no matter what's in there, if that's all it is, it's going to be 1. Anything to the first power is always itself, so that's going to be a plus b. Anything squared will be it written times itself, so that would be a plus b times a plus b. And if you do the math on that, that's going to be a squared plus, you're going to get ba twice, so 2ab plus b squared, those last terms square. And once you get a little bit more involved in that, then you have some multiplication to deal with. So a plus b cubed you can think of as a plus b times a squared plus 2ab plus b squared. So that's going to look like this. Now I challenge you to see if you can multiply these together yourself. And if that's the case, maybe pause the video and try it. But I'm going to just do it using FOIL methods. I don't have a lot of room for box. So it's going to be a cubed 2a times b, so it's going to be plus 2a squared b. Then I have this a times b squared, so plus ab squared. And I'm doing this again with a b, so it's going to be b times a squared, so that would be a squared b. 2 times a times b, so plus 2ab squared. And b times b squared, which is going to be b cubed. And when you work that out, that's going to end up being a cubed plus, these are like terms because they have the same variables and exponents. So that's going to be 2 plus 1, so 3a squared b. And the same thing here, 3ab squared plus b cubed. And that can get pretty complicated. You know, the more that you get that exponent higher, the more complicated this is going to be. And we don't want to have to keep doing that. All right, we can do the same thing with the fourth power. It's going to be a plus b times all this stuff up here. And that's, that's a lot going on here. That's going to be a to the fourth plus 3 times a squared times a, so 3a cubed with that b there. And the same thing here, 3, and I'm not going to keep connecting these, but 3 times a squared b squared. The next ones I'm going to connect are here, a times b cubed, so that's going to be plus ab cubed. And I'll do the same thing with the b's. This is going to be a cubed b. Look how that lines up perfectly under here. 3a squared b squared. And 3ab cubed. And the last one's b times b cubed, so it's going to be b to the fourth power. And that gets pretty tedious. And if you miss a note, you're gonna throw the whole thing off. So it's going to be a to the fourth plus 4, that's a 1, a cubed b plus 6 a squared b squared plus another 1 and 3, so 4 a b cubed plus b to the fourth power. So it's a lot of work just to get all those. And I'm not going to ask you to do all that, but I want you to see the progression of what those look like. So now let's look at, and pause the video if you need to and write this down and rewind it, but let's look at the patterns here. Okay, this is the same thing without all the work that I had. I want you to look at the numbers, okay? 1, these are 1s. 1 plus 1 is going to give you 2. 1 plus 2 is going to give you 3. 2 plus 1 is going to give you 3. Then there's some 1s on the outside. Again, 1's on the outside. We'll look at the 1 and 3. That's going to give you 4. 3 and 3 is 6. 3 and 1 is 4. And that pattern continues. Also look at the exponents. It's the a starting off at the highest, whatever exponent it is. Then it's going to count down until it doesn't exist, but the b's going up. So there's no b, then there's a b and a b squared. A cubed, a squared, a to the first, no a. No b, b to the first, b squared, b cubed. And you notice they're going in opposite directions. The exponents are going down, counting from the highest to the no exponent. And the b's are counting up from no exponent all the way to the highest exponent. So that's a definite pattern, and that'll exist for all of these. So as we're going through, I'll just fill in a couple notes here that you have. These are coefficients, so let's look at that. The coefficients, they're going to form a pattern that can be displayed in a triangle formation called, and we call that Pascal's triangles. It's named after a famous mathematician who I guess is credited toward discovering this. And that triangle is what you see over here when these numbers expand. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 1, 5, 10, 10, 5, and 1. And that pattern can keep going. I could do as high of a power as I wanted to, but those numbers represent what's in Pascal's triangle. Each coefficient is the sum of the two coefficients above it. The coefficients are symmetrical or symmetric. I'm not sure if that's symmetric or symmetrical, but it doesn't matter. They're gonna increase at the beginning. So you'll notice it's 1, 2, and then it's going to decrease at the end. Back down to 1. Again, 1, 3, 3, 1. Sometimes the middle term, if it's an even number, the middle ones are going to be the same, like these 10s here. The nth row will always have n plus 1 terms because you're expanding a binomial, and a binomial always starts with 2 terms anyway. So it's always going to have one more term than the highest exponent. So that's 5 as the degree, and there's going to be 1, 2, 3, 4, 5, 6, n plus 1 terms. Okay, just a couple other housekeeping things with the binomial theorem. The exponent of the first term is, it's going to be n. The exponent of the last term is n. And the sum of the exponents will always be n. So let's look up here for a minute. Let's look at the fourth power one. That exponent's 4. These two exponents add to 4. Same here, these 2's add to 4, 4, 4, 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and 5 and 5. So it's always going to be symmetrical, and they'll always add to n. In successive terms, the exponent of a decreases by 1. So the a value is going to start off, and it's going to decrease by 1. And the exponent of b increases by 1. So the b will start out with no exponent, and then it'll get up 1 higher as it goes throughout the time. And of course, there's a chart you can fill in to kind of help guide you. This is 1. Pause it and see if you can fill it all in and check it with me. This is 1, 2, 1. These two add to 2. These two add to 3. 1, 4, 6, 4, 1. And I'll let you fill in the rest. And I want you to pause it, and I'll just have the answers here.